For this one, we want to solve a system of linear equations, both of which are in two variables, and they're both inequalities as well. So there's going to be a lot of shading and regions going on. So let's jump right in here. Note that these are both of the form y equals mx plus b. And in this form, m is the slope and b is the y-intercept. Okay, well, I guess the bottom one's not quite there yet, is it? Let's fix this up. Let's rearrange it a little bit. This is y greater than negative x minus 1. So I will graph this bottom one in blue and the top one in red. Okay, so we can see what's going on here on a graph. Okay, so this top one, let's just graph the line y equals x minus 3, and really this is 1 over 1x. Right? When there's nothing there, there's an invisible 1 there, so the slope of 1 is 1 over 1, which is a perfect diagonal going up and to the right. Up 1 over 1, up 1 over 1. So we have a y-intercept of negative 3. Okay, and then we go up 1 over 1, up 1 over 1. That will eventually cross us in the x-axis at 3, and because it's a perfect diagonal line, and we have a equal sign here, so that tells us it's a solid line. Okay, so that's good news. Here we go. Let's connect everything up like so. Okay, and when it's in y equals mx plus b form, greater than or equal to is shade up, and less than or equal to is shade down. That works because we're in y equals mx plus b form. Okay, so here we go. So for this red one, we're at greater than, so we're going to shade up. And I'm just going to put a couple arrows. I don't want to overdo it because our shaded region is only going to be where the red and blue overlap. Okay, so let's check out this blue case. Here we have y equals negative, well, 1 over 1x minus 1. Okay, so here our slope and our y-intercept is negative 1. Okay, and our slope is negative 1, so it's down 1 over 1. Down 1 over 1. All right, it's a perfect diagonal going down. Our line needs to be dashed because there is no equal sign here. So I'm going to say right here, this is a dashed line. You could also do a dotted line. Okay, so it should look something like this. Dash, dash, dash. Going all the way down like so. Okay, and then this is greater than here, so it's going to be shading up again. So I'm going to draw in some arrows just to get the general idea of where the shading happens. Okay, and now our final answer is where the shaded regions overlap. Final answer is where shaded regions overlap. Okay, so so we have the red stuff going up, we have the blue stuff going up, but where they overlap is just in this region in the middle here. So I'm going to fill that in like with black here to show that that is indeed my final answer. Okay, and when you do this on your own, whatever you do, some people like to erase it, some people like to make a new graph, some people like to use a different color, some people like to do what I did and just make their final answer very clearly much darker, but you need to be clear where your final answer and shaded regions are. If every single thing is shaded and it's impossible to tell which region is your final answer, that's not going to count for all the points. So make sure you get just your just the overlap in your final answer on these.